You think you already know Saturn, the pretty planet, the one with the rings, the one that looks almost like a toy sitting inside a backyard telescope. You've seen the photographs before. You've probably even used one as a screensaver at some point in your life. But I need you to genuinely understand something right now, before this video is even 2 minutes old. Saturn is not pretty. Saturn is not a toy. Saturn is actually one of the most violently extreme, deeply strange, and genuinely unsettling environments anywhere in our entire solar system. And for decades, it had been quietly hiding its worst secrets from us, until the James Webb Space Telescope finally pointed directly at it and found things that have left scientists completely speechless, things no planet should logically be able to do, things with no clear explanation whatsoever, things that have forced researchers to fundamentally rewrite what they thought was, even possible, inside a planetary atmosphere. This is exactly what Webb just revealed, and by the time this video ends, you will genuinely never look at Saturn the same way again. Entire solar system, sitting right behind Jupiter. Its diameter measures roughly 9.5 times the diameter of Earth. If you could somehow hollow Saturn out completely and fill the empty space with planet Earths, you would need approximately 760 of them to fill it up. The equatorial winds on Saturn blow at speeds exceeding 1,000 kilometers per hour. That is genuinely not a typo. Over 1,000 kilometers per hour. The fastest wind gust ever recorded on Earth during an actual hurricane was around 400 kilometers per hour. Saturn's permanent baseline wind speed, not even during a major storm, its ordinary equatorial winds, is more than double that figure every single day, continuously across the entire planet. Now, let's talk about Saturn's North Pole, because this is genuinely where things start getting disturbing. Saturn's North Pole is home to one of the most bizarre natural structures ever discovered anywhere in the entire known universe. It's a storm, an enormous, permanent, unceasing storm. But unlike literally every other storm we've ever found on any other planet anywhere, it isn't circular. It's a perfect hexagon, a six-sided geometric shape formed entirely out of clouds and gas, and it has been steadily rotating around Saturn's North Pole for as long as we've actually been able to observe it, which is now well over 40 years, dating back to the Voyager spacecraft flybys in the early 1980s. Really let that sink in for a moment. A precise geometric shape, sustained inside a planetary atmosphere on a planet the size of Saturn. As Professor Stallard described the finding, the research team had originally expected to see broad, diffuse bands of emission spread across the upper atmosphere. Instead, they found fine-scaled patterns of beads and stars that, despite being separated by huge distances in altitude, may somehow be interconnected, and may also be genuinely linked to that famous hexagon sitting deeper within Saturn's clouds. Really think about what that implies for a moment. If these structures truly are connected in some meaningful way, then the hexagon sitting at the bottom of Saturn's atmosphere isn't simply a weather pattern confined neatly to the clouds alone. It's somehow influencing, or being influenced by, processes happening hundreds of kilometers above it, reaching all the way up through the stratosphere and into the ionosphere itself. Some form of vertical coupling, some kind of energy or information exchange, appears to be occurring simultaneously across multiple completely distinct atmospheric layers. On no other planet we currently know of has anything remotely like this ever been observed. Not on Jupiter, not on Uranus or Neptune, and not here on Earth either. Now, as genuinely mind-bending as those dark beads and that broken star pattern already were, Webb actually had one more major Saturn revelation still to deliver. And this particular one managed to solve a mystery that had genuinely been haunting planetary scientists for over 40 consecutive years. Ever since Voyager 1's flyby of Saturn back in November 1980, scientists had been struggling to accurately measure exactly how fast Saturn actually rotates. On the surface, that sounds like it should be a fairly simple question to answer. You observe the planet, you track a distinctive feature as it goes around, and you time how long that takes. But Saturn made this task remarkably difficult in practice. Unlike Earth, Saturn has no solid surface whatsoever. It's a gas giant essentially all the way down to its core. There are no mountains or fixed landmarks anywhere to actually track over time. So scientists instead relied on radio emissions linked to Saturn's powerful magnetic field and its aurora as an indirect proxy for measuring the planet's true rotation rate. Voyager 1 originally measured Saturn's rotation period at roughly 10 hours and 40 minutes. When NASA's Cassini spacecraft finally arrived at Saturn back in 2004, it measured that same rotation using essentially the same underlying method, and it got a genuinely different answer entirely. The measured period had apparently lengthened by about 6 minutes compared to Voyager's earlier figure, and then it kept right on changing across subsequent years of continued observation. Cassini's measurements shifted again and again over time, strongly suggesting that Saturn's actual rotation rate was somehow fluctuating unpredictably over time. This represented a genuinely enormous problem for planetary science. A planet simply cannot casually change how fast it physically spins on its axis. Doing so would require some kind of enormous energy exchange or angular momentum transfer, for which there was no plausible physical mechanism available. Planets simply don't randomly speed up and slow down like that. The underlying physics doesn't reasonably allow for it, on the timescales these particular measurements seem to be suggesting. So either the measurements themselves were somehow wrong, or something genuinely bizarre was actually happening out at Saturn. For roughly 4 full decades, the scientific community openly argued back and forth about which explanation was actually correct. Webb finally answered that long-standing question. That same November 2024 observation, later published in the Journal of Geophysical Research, Space Physics back in March 2026 revealed the underlying truth. And the truth turned out to be even more fascinating than almost anyone had originally predicted. Saturn's rotation was actually never changing at all. The planet had been spinning at essentially the same steady rate the entire time. The earlier measurements were indeed wrong, but genuinely not because of any simple instrumental error. They were wrong because of something else entirely happening deep within Saturn's own atmosphere. Here's what was actually going on beneath the surface of the mystery. Saturn's aurora, its own direct equivalent of Earth's northern lights, forms when charged particles arriving from space funnel steadily down along the planet's magnetic field lines and slam directly into its upper atmosphere. That aurora heats the surrounding atmosphere in exactly the regions where it burns most intensely. That localized heating, in turn, creates genuinely powerful atmospheric winds. Those same winds, moving steadily through the charged plasma sitting within the ionosphere, generate their own electrical currents. Those electrical currents then subtly change the physical properties of the very auroral emissions scientists had been relying on to measure the planet's rotation in the first place. And those altered emissions produced a consistently false reading on the actual rotation period. But that's genuinely not the whole story either, because those same electrical currents generated by the winds then flow back through the entire system and actively power the aurora all over again from scratch. The aurora heats the atmosphere. The heated atmosphere drives powerful winds. Those winds generate electrical currents. Those currents, in turn, power the aurora once more, and the aurora then heats the atmosphere again, restarting the entire cycle. It's a fully self-sustaining loop, essentially a planetary heat engine running continuously, powered directly by Saturn's own magnetic field and its own northern lights, and in the process, quietly producing exactly the kind of misleading electrical signatures that fooled essentially every instrument we'd ever pointed at Saturn for a full 40 years running. Professor Stallard actually called it a planetary heat pump. In his own words, Saturn's aurora heats its atmosphere, the atmosphere drives winds, and the winds produce electrical currents that go on to power the aurora once again. And so the entire cycle simply keeps going indefinitely, feeding itself continuously. For decades, we genuinely knew something strange was happening with Saturn's apparent rotation rate, but nobody could actually explain why. Researchers eventually showed the phenomenon was being driven by atmospheric winds, but still didn't fully understand why those specific winds even existed in the first place. These new Webb observations finally provided the missing evidence needed to close that entire scientific loop for good. A genuine 40-year-old mystery, finally resolved by just 10 hours of careful observation using precisely the right scientific instrument. Now let's step back for a moment and really think about what all of these individual revelations together actually mean. Because I think there's a much bigger picture here that's genuinely easy to overlook when you're only looking at each individual discovery in isolation. Saturn sits right here inside our own solar system. It isn't some distant exoplanet orbiting a far-off, unreachable star somewhere. It's essentially right next door, a few doors down in cosmic terms. We've already been studying it with telescopes for well over 400 years now. We sent an entire billion-dollar spacecraft, Cassini, to actually orbit it directly for 13 straight years, from 2004 all the way through 2017. By any reasonable measure, we genuinely thought we already had a fairly solid understanding of exactly what Saturn is and how it actually works. And then Webb looked at it with a considerably sharper eye than anything we'd ever previously pointed at it. And within a single 10-hour observation window, it uncovered dark beads that nobody even knew existed, a broken star pattern nobody had ever seen before, possible atmospheric connections spanning hundreds of kilometers of altitude that no existing planetary model had ever predicted. And it finally settled a decades-long scientific argument about rotation that had been quietly simmering since the early 1980s. This is exactly what makes Webb so genuinely extraordinary, and honestly, so humbling at the exact same time. It keeps demonstrating, again and again, that even the things we thought we already fully understood, even planets sitting right inside our own solar system that we've studied for centuries, still hold profound secrets hidden just below the resolution of whatever instruments we previously had available. The universe keeps an enormous number of things genuinely hidden from view, and the moment you finally build a sharper eye, it reveals entire layers of complexity and strangeness that make you realize just how much you genuinely didn't know before. Saturn's dark beads sitting in the ionosphere remain unexplained to this day. The precise reason 2 of the 6 arms are missing from that star pattern in the stratosphere remains genuinely unknown. The exact mechanism by which the hexagon far below might actually be communicating with structures hundreds of kilometers above it is still being actively worked out. The data Webb collected has answered some long-standing questions while simultaneously opening up an entirely new set that scientists are only just beginning to seriously investigate. There will inevitably be more observations, more published papers, more revelations still to come. And in the meantime, Saturn simply sits there, roughly 886 million miles from Earth at its closest approach, surrounded by its iconic rings made of ice and rock, its equatorial winds still blowing at over 1,000 kilometers per hour, its permanent geometric superstorm still spinning steadily at the North Pole, its broken star and dark beads and self-sustaining auroral heat engine quietly continuing to make it one of the most extreme and genuinely extraordinary places anywhere in the solar system. But there's actually something even deeper worth sitting with here. Something that goes well beyond these individual discoveries and speaks directly to why Saturn specifically, out of all 8 planets in our solar system, keeps surprising us in ways no other planet quite manages to match. Jupiter, after all, is physically larger. Jupiter has its own storms, its own powerful magnetosphere, its own genuinely complex atmospheric dynamics. But somehow, Saturn keeps producing phenomena that have absolutely no direct parallel anywhere else in the entire solar system. The hexagon alone is enough to make it genuinely unique. No other gas giant anywhere has a persistent geometric storm sitting at its pole. Jupiter has an oval-shaped storm instead. Saturn has a hexagon. That fundamental asymmetry alone is something planetary scientists have spent decades trying to fully explain. And while the broad underlying mechanism is now reasonably well understood, the hexagon's genuinely extraordinary stability across more than 40 years inside a turbulent, gas-rich atmosphere with wind speeds that would violently shred almost anything here on Earth remains genuinely remarkable in its own right. Then there are Saturn's famous rings themselves. From a distance, they look genuinely beautiful, almost delicate. Up close, there's something else entirely. The full ring system extends outward roughly 282,000 kilometers from Saturn's center. At the exact same time, they're astonishingly thin relative to their enormous width. In most places, the main rings measure only about 10 meters thick. You could easily fit multiple Mount Everests inside the ring system across its width, yet the rings themselves are barely thicker than a 5-story building. They're made predominantly out of water ice, mixed with some scattered rocky debris throughout, and the individual particles within them range enormously in size, from tiny grains smaller than an ordinary grain of sand all the way up to individual chunks the size of entire houses. Within those rings, there are genuinely intricate structures, waves, spirals, clumps, gaps, delicately braided patterns, and mysterious dark spokes of material that appear and then disappear over time. The rings aren't simply a beautiful visual backdrop sitting behind the planet. They're an enormously complex dynamical system, actively shaped by the gravitational influence of Saturn's dozens of orbiting moons, constantly evolving even on timescales humans can directly observe. Webb has also been actively studying those same rings in its own right. In infrared light, Saturn's rings transform away from their familiar pale appearance into a distinctly glowing blue color simply because the water ice they're made of is highly reflective at infrared wavelengths. The planet's poles glowed in a strange gray-green color at wavelengths tuned to probe the upper atmosphere, and Saturn's characteristic banded cloud structure revealed entirely different patterns of depth and underlying chemistry than any visible light images had ever previously shown us. Webb and Hubble were actually used together back in 2024, pointed at Saturn roughly 14 weeks apart, allowing scientists to effectively slice through Saturn's atmosphere at multiple altitudes simultaneously, essentially peeling back its many layers one at a time. That combination of observations produced the most detailed 3-dimensional portrait of Saturn's overall atmospheric structure ever assembled. What emerged was a picture of a planet with enormously complex atmospheric chemistry, clouds and hazes sitting at different altitudes made of genuinely different materials, temperature gradients, wind shears, and active chemical reactions happening continuously at essentially every altitude level. Saturn isn't really a single uniform atmosphere at all. It's actually dozens of distinct environments stacked directly on top of one another, each interacting continuously with the layers above and below it, in ways scientists are still only just beginning to properly map out. And then, of course, there's the entire moon system surrounding Saturn. Saturn currently has 146 confirmed moons, according to recent counts, more than any other planet anywhere in our solar system. Some of them are genuinely small, irregularly shaped rocks that were simply captured by Saturn's gravity billions of years ago. But several of them rank among the single most scientifically fascinating objects anywhere in the entire known universe. Titan, Saturn's largest moon, is actually bigger than the planet Mercury. It has a thick, nitrogen-rich atmosphere that, in some genuinely important ways, resembles early Earth more closely than anything else we currently know of. It has actual lakes, rivers, and seas sitting right on its surface, but they're filled not with liquid water, but with liquid methane and ethane instead. Titan literally rains liquid methane down from its orange, smog-covered skies. Scientists consider it one of the most promising places anywhere in the solar system where some form of chemistry related to the fundamental origins of life could potentially be occurring, though certainly not life exactly as we understand it here on Earth. Then there's Enceladus, a relatively small, ice-covered moon that ranks among the single most astonishing places anywhere in the solar system. Beneath its completely frozen surface, Enceladus harbors a genuine global liquid water ocean, kept liquid by tidal heating generated by Saturn's gravity, which continuously flexes and squeezes the small moon as it orbits. Through cracks in the ice near its south pole, the hidden subsurface ocean actively vents powerful geysers of water vapor and ice particles directly out into space, creating an enormous plume that Cassini actually flew through and directly sampled during its mission. Inside that plume, scientists detected water, salt, carbon dioxide, hydrogen, and various organic molecules, essentially all the basic ingredients that life here on Earth genuinely relies on. Whether microbial life could actually exist within Enceladus's hidden subsurface ocean remains one of the most seriously debated open questions in astrobiology today. All of this together, the rings, the moons, the hexagon, the dark beads, the broken star, the self-sustaining auroral heat engine, the 1,000-kilometer-per-hour winds, exists within the exact same planetary system, orbiting the exact same gas giant, all sitting well within reach of our current telescopes, and eventually our future spacecraft as well. Saturn genuinely isn't a single discovery. It's essentially a solar system contained within a solar system. Every single layer of it, every moon, every ring, every distinct atmospheric tier, contains phenomena we're still actively working to fully understand. Webb has already peeled back several of these layers over just the past year alone. It has resolved a 40-year-old mystery surrounding Saturn's rotation. It has revealed structures within the upper atmosphere that have no known parallel on any other planet. It has produced the single most detailed infrared portrait of Saturn's atmospheric layers ever assembled by scientists. And remarkably, it has accomplished all of this essentially as a side project. Webb's primary mission is actually focused on things far beyond our own solar system entirely, exoplanet atmospheres, the most distant galaxies ever observed, and the earliest moments of the observable universe itself. Saturn is really just one single stop along an extraordinarily packed observational schedule that covers essentially the entire observable cosmos. And yet, even in passing, even through observations that weren't the primary focus of the mission at all, Webb is actively transforming what we know about our own nearest planetary neighbor. Just imagine what it might reveal if we dedicated an entire dedicated mission specifically to studying Saturn using Webb-class instruments purpose-built exactly for that job. A dedicated Saturn orbiter equipped with the infrared sensitivity of Webb, combined with the close proximity Cassini once enjoyed. That particular mission hasn't been launched yet, but the data streaming back from Webb right now is quietly building the entire scientific case for exactly that kind of future mission, simply by showing us just how much there genuinely still is left to learn. We sent Cassini all the way to Saturn and spent 13 full years orbiting it, coming back with enough accumulated science to fill entire libraries. We then turned Webb towards Saturn for just 10 total hours and found phenomena that nobody had ever seen before and that nobody can currently fully explain. If that's genuinely what 10 hours alone can accomplish, imagine what an entire additional decade of dedicated observation might eventually reveal. The honest answer to that question is almost certainly something nobody could accurately predict today, because that's really just what Saturn keeps doing to us over and over again. It keeps showing us that no matter how much we think we already know, no matter how sophisticated our instruments become, no matter how many decades we've already spent studying it closely, there's always another hidden layer, always another mystery, always another structure or pattern or process quietly hiding just beyond the edge of whatever we could previously see. The planet that looks like a simple toy through a backyard telescope, the planet people casually point to as the prettiest object in the night sky, the planet with the rings. That very same planet is also a world of geometric superstorms, self-sustaining atmospheric heat engines, broken star patterns floating silently within charged plasma, dark beads slowly drifting through auroras at altitudes of 1,000 kilometers, winds that would make even Earth's worst hurricanes feel like a gentle summer breeze by comparison, and an entire moon system that contains at least two of the single most promising locations anywhere in the solar system in our ongoing search for life beyond Earth. Scary isn't really the right word for it. Magnificent, genuinely terrifying, and endlessly surprising. That's really what Saturn actually is. And James Webb has genuinely only just started looking. So the next time someone shows you a photograph of Saturn and casually says, "Look how pretty," you'll actually be able to tell them what's really going on inside that image. Behind those beautiful rings, inside that golden atmosphere, high above that perfect hexagon, dark beads are quietly drifting through an invisible ionosphere, and a broken star sits floating within the stratosphere, caught inside a self-sustaining loop of heat, electrical current, and wind that has been running continuously without a single interruption since long before humans ever existed at all. And Webb is watching every bit of it right now, recording all of it carefully, quietly, helping us understand, one extraordinary discovery at a time, just how strange and just how genuinely alive this planet really is.